Hello, everyone. So another MathCON problem. This is a grade 10 algebra problem, okay? So we have a number m is given as a fraction that will continue forever. And then some people may call these kind of like fractions are self-similarity because, if you just look at the numbers you are given carefully, you see actually they are just similar to like every single step. So 1/3 plus 1/3 plus 1/3, it will just continue forever. So, if you say this guy is equal to x, which is one of the choices, right? And then this guy is actually same as this part, okay? And that is actually the same as that guy because, 1/3 plus 1/3 plus 1/3 plus that will continue forever. So this expression like this number right here and the question that we are given is actually the same thing because when you think about the infinity of like those fractions, having one more of those like 1 and 3s doesn't really make any difference. So which is why the whatever we are looking for is actually the same as this part of this whole fraction. So which is why we can go ahead and write this as like 1/3 plus this whole thing was x is equal to the result was is also x. Again, if you are not really satisfied with this, please take a look at maybe pause this video and make sure you convince yourself before you move on, because that is something you really need to get before you move on. Okay, so now you can just go ahead and like solve this equation. I can just write over 1, do cross multiplication. So that will be x times 3 plus x equals 1 by 1, which is just 1. So expand those, that will be 3x plus x squared. When you expand these guys, equals 1. So we have a quadratic equation. So I can pull everything one side. So the square term, I will just write first. And then you have 3x if you subtract 1 from both sides. So you will get -1 equals 0. So at this point, the rest is just up to you. So since I don't really see easily to factor this guy, and I can not really easily like factor this guy, maybe that's not easily possible, or maybe there's no way to do so anyway. And you may use the completed square if you want to, which is I prefer usually. But in this case, I'm going to use the quadratic formula, okay? So because that is something we want to remember as well. So the quadratic formula was like minus b plus or minus b squared minus 4ac. All this quantity divided by 2a, right? And then if you remember, this is my general form. Okay, some people call it standard form of the quadratic. So the a, b, c are the coefficient of the terms, and then this is how we use it. So now if I want to plug the numbers in my quadratic formula, in our case, a is 1, so that's the coefficient of this guy, and b is the coefficient of the linear term, which is 3, and c is the constant number, which is -1. So the solution will be minus b minus of 3 plus or minus b squared, which is 3 squared, minus 4 times a, which is 1, times c, which is also -1. And this is on the radical. This is divided by 2 times a. So, this is 9, and then this minus, and this is minus. If you multiply two negatives, you get a plus. That's going to be 4. 9 plus 4 is 13. So that will be -3 plus and minus root 13. This all over divided by 2. So, some people write this the other way around. So the minus at the bottom, plus at the top, which doesn't really make any difference. And make sure, we are just writing like when you saw this quadratic equation, we got two solutions, -3 plus root 13 over 2, -3 and minus root 13 over 2. But since we are keep adding like positive numbers right here, there is no way to get this as a negative. So we should take the positive version of this guy. Since root 13 is something larger than 3, but lesser than 4. So I need to take the plus version, otherwise the numerator cannot be negative. So my solution should be -3 plus root 13 over 2. So if I take the negative of this, that will be numerator will be negative, which is not reasonable for our question to get a negative result. So which is why this is my actually the only answer, okay? Which is, I guess, just choice E. Okay, so I hope that makes sense. So this was a 5 points problem. So, and then the question kind of testing a couple of skills. First, seeing the self-similarity, and the second, using the quadratic formula at some point. That is two things that we need to maybe get better at this problem, okay? So I'll see you guys in the next problem.